Hey, Mr. Brewer here with you for week three chemistry class, where we're going to be looking at a review of chapter eight, where we did covalent bonding, and look at a few different things. Last chapter, we looked at ionic bonding and how there's a transfer of electrons, and then you get ions. You get a cation and anion, positive and negative, and they stick together because opposites attract. Now we're going to look at with chapter 8, the covalent bonding is going to be a little different. So things we're going to focus on, being able to make Lewis structures. We'll talk about how to make those. We're going to look at the VSEPR theory, which is going to give us the molecular geometry and be able to predict the shapes that the molecules will have. We'll look at a couple of different hybrids, and then the polarity of the molecules and what the forces are that hold those together. So a little bit longer of probably a video session today. So we look at it. Bonds, anything that's going to hold the atoms together. And there's basically two types. There's what we talked about last chapter, ionic bonds, which was the transfer of electrons. And if you remember, it makes a formula unit. We had to do the crisscross to get the stuff to make the formulas. And then you'll have what we're talking about this time, which is covalent bonds. It's the sharing of electrons. Now, what that eventually gives us is the overall unit's going to be called a molecule. So you have two types of bonds. You have the ionic bond, which is going to be an ionic compound. Most of the time we just say it's a compound. And then you have covalent bonds, which is going to be a molecular compound, which a lot of times we're just going to call a molecule. So it becomes just words that you would use where you say compounds. Most of the time we're talking about ionic bonds, and molecules, you're talking about covalent bonds. So when we find molecules, one of the things that it's basically a neutral group of atoms that are going to be held together by sharing of electrons. And one of the main examples that we started off talking about was with oxygen. The oxygen that you breathe is technically not one atom of oxygen. It's a molecule of oxygen, which means they are bonding with each other. Two oxygen atoms bonded together. Two of the same atoms bonded together is going to form what's called a diatomic molecule. In the book, and if you remember, we focused a lot on the diatomics and how, not only how they form, but just the fact that they are going to be able, you're going to have to be able to know those are diatomic. So we just tried to memorize them. And it was the rule of sevens. There's 7 elements that form the diatomics, starting with hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine makes the 7 on the periodic table. Those are going to be your diatomic molecules. So if you look at the simplest on how H2 or hydrogen forms, hydrogen never exists in nature by itself. It always at least bonds with itself or with something else. Basically over here you have one hydrogen, which is just a proton. You have a hydrogen over here with one proton. Each one has their own electron. And if you remember, hydrogen wants to have 2 electrons because it wants to be like helium. It's the only one that doesn't form that octet. It's happy with a duet. It only wants 2 to be happy. So if you have one hydrogen here has one, and you have one, and they get close enough together, that electron then can go around both of them, and then you would end up having both of them being happy. Now, what we find out with covalent bonds is it's only going to happen between nonmetals. Ionic compounds are metals and nonmetals bonded together. 2 nonmetals are only going to make a covalent bond. And why is that? Because they don't give away electrons. They want to gain more electrons. Whereas we said a cation wants to give away an electron. Well, guess what? An anion wants to gain. Well, all nonmetals want to gain, so they can't really form that ion. They have to do it by sharing. And when you put 2 together, if we had, remember, fluorine we just said was a diatomic, when you make a picture, and this is called a dot diagram because of the dots, if I look around fluorine, which normally has 7 valence electrons, 1, 2, 3, 4, 5, 6, 7, but when it shares one with the other fluorine, it gets its 8. And then we would go ahead and go to the other side and look at it and guess and count all the electrons around it. It has 8. So in doing so, they both are happy. They both end up satisfying that octet rule. Both of them are having their 8 valence electrons around them. It's just in a different way than what ionic bonds do.